Hey, what's up, guys? Okay, today we're going to work on this problem that looks like this guy here. Okay, so in the problem, you got it. It's question 12, I think. Web work 12, or I think question 10. Question 10. Web work 12. So you start at A, and this is a lake here. This whole circle is a lake, and you can paddle through the lake here along purple line, and then when you get to the edge, you can run or bike or whatever, but you're traveling on land there, and you go at different speed on the pink line. Then you go in the purple lines. The question is, where do you aim yourself? In other words, how do you choose this beta angle so as to minimize your time? Okay, and you'll notice that if you make the beta angle very large, in other words, close to 90, you're going to have very little time on the water and then a long time on the outside. And then you could do this too, where you could aim like right across the lake, and that would be the shortest distance, but it might not be the shortest time. Okay, that's the problem. So yeah, so the question is we want to set up an equation in terms of one variable that measures the time it takes to get from point A here to point D here. All right, so let's look at let's look at this picture first of all and see what we can get for free. I didn't notice this at first, but we actually there's two ways to do this problem that are not too bad. First is you've got a triangle here, A to B to C, this triangle here. We know this side length, BC, is always 2 because that's the radius of the circle that just draws from B to C. We also know the length from A to B, that's length 2. All right, and then this angle is theta, and then this angle up here, in other words, ACB, that angle is also going to be this beta, right, because it's an isosceles triangle. So what you can do here is you can actually use oh, and that, by the way, gives you this angle here, right? We don't know this is a 36.95, by the way. We'll leave that as a theta in our calculation. So that's our one variable that we've used. And we want to express everything in terms of that one variable. So we're out of variables to use. Anyway, this is theta here. This is 180 minus 2 theta here. So we know these variables, or these angles. Anyway, you can use cosine law to find out the length of this guy here. Okay, that's one way to do it. That doesn't require too much craziness. Another way to do it is to recognize that this triangle ACD, the one that I've colored in here, is actually a right triangle. So I've measured this alpha angle up here, okay, and that's not, I didn't fix that angle, that's not fixed, it's just measuring whatever angle that is. That's a 90-degree angle, okay, it doesn't matter where it goes. Isn't that kind of cool how you can move this around and this angle stays the same? That's always true. It doesn't matter where A and D are. A could be here, D could be here. When you move this around, it won't be a 90-degree angle, but the angle won't change. Whatever it is, it won't change. Okay, so those are two ways you can count. Oh, so by the way, now that we know this is a right triangle from ACD here, we can express this length AC in terms of this angle theta, right? If we kind of look on our side here, the hypotenuse of that right triangle is length 4. That's AD here. That's what I've got there. And obviously that's always 4 because it's just 2 radiuses. Length B we don't know, but we don't care. We don't need it. With basic trig using cosine, I guess that'll do that one over that one. Adjacent over hypotenuse. That'll give us, we'll be able to express this purple line in terms of theta. So that's probably the easiest way to express that purple line. Okay, cool. So purple line is done. We know how to express that in terms of one variable theta. Let's see if we can express E, the pink line, in terms of theta. If we can express E in terms of theta, then we're going to be able to get the times for both of these things without too much trouble. So let's talk about radians for a second. So what is a radian? A lot of people are like, oh, it's an angle. It's like, well, like, I guess sort of it's an angle, but really it's a distance. Okay, a radian is a distance. A radian is like 1 radian. I'll tell you what 1 radian is. For a circle of radius r, 1 radian is you take that radius and you string it along the edge and see how far you get. That's 1 radian, it's 1 radius along the circumference of that circle. Okay, that's why pi radians brings you halfway around the circle. If you took pi of your radiuses and strung them along this thing, you would get halfway around. 2 pi radians brings you all the way around. Okay, A radian is a radius along the edge. Okay, so once we have this, and if we had this orange angle in radians, then that tells us exactly how far we get along. It's just whatever this is, if it's like, you know, like 3 radians or whatever, not, it won't be 3, but like, whatever, it would, you just take 3 times the radius is this length, right? So that's, if you understand radians in that way, then just getting this length is very easy. It's just you need to know how many radians it is, and then you just multiply that by the radius, and that of course gives you the length around. Okay, so there's a formula for it, but as you guys know, I don't really like formulas that much because it doesn't help you learn. It's more important to know what the hell is going on and why the hell it's working. So anyway, that's what the length E is. Oh, sweet, we have the radius of this circle. What do you know? It's 2. Okay, so as long as we have the measure of this angle, this length E will be 2 times the measure of this angle. Now, here's the, I think it's called central angle theorem, which states that this angle in here is going to be twice the angle about here, which is awesome because otherwise we would have had to introduce a new variable to generate this length here. But we don't have to. So this is just 2 theta. So the measure of, excuse me, of E is going to be 2 times 2 theta, where theta is our beta. So now we can express E in terms of that original variable also. So we've expressed purple in terms of that original variable, theta, which is, right now it says 34.2. And we've also expressed E in terms of that. And that's the hard part of the question. Well, actually, there's a tricky part. It's not a hard part, it's a tricky part. So, okay, I wrote some stuff up. Let's at least go to that for a second. Okay, see the GeoGebra diagram. You guys can see that. And I'm going to post that in the description, so if you want to play around with that, of course, as always, you can go play around with that. It's kind of fun, by the way, just like building these things in GeoGebra. It's pretty sweet. Anyways, length of segment A can be calculated. Okay, I did this, I did this, I did this. Let's suppose your speed over water. Okay, here's the new stuff. So let's suppose your speed over water is W and your speed over land is S. Here's the formula for total time around the circle, well, like through and around the circle, dependent on our pink angle CAD. All right, what's the pink angle? This one here. That's CAD. Okay, so this is our theta. So in the writing, I'm going to make that my theta. All right. So let's see here. So AC, which is that purple line segment, is going to be 4 cos theta. I just do the like calculate that yourself. That's just basic trig. Cosine of the theta is equal to adjacent over hypotenuse, so blah, 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 okay? Do that. Now, E, we talked about, that's 2 times that angle, okay? Now, the total time is going to be the distance you traveled. I think about how long it takes me to travel 100 kilometers if I go 5 kilometers an hour. I'm trying to see how many times that 5 kilometers fits into the 100, okay? That's going to be the total time. So it's distance divided by speed gives you time, all right? And then here, this is the distance around the arc, and then this is the speed at which you travel around the arc. Okay, so that's your formula. Everyone's going to have the same formula. The numbers aren't going to be any different for anyone unless your circle is a different radius. So that's the hard part. So now you just plug in whatever your values are for W and S. Take the derivative, set it equal to 0. This is actually a fairly simple calculation question. Now, okay, now that we've set it up in this way. So you're going to get the derivative, set it to 0, find your critical points. Now, caution. This is the tricky part of this question. Like I said, it's not hard, it's just tricky. So remember when we were calculating extreme values like on a graph, and they would say, find the maximum between like -4 and 7. Remember, you always plug in the -4 and the 7 because those might be the extreme points over that interval. That's what you need to do for this question, okay? The critical points you plug in that you solve for might not actually be maximums and minimums over your interval. Now, what's your interval? Well, remember, we're solving for theta. Theta is this guy here. We're looking for the optimal theta, so the optimal spot to aim. Where do we aim along this like river or lake or whatever, the lake, to optimize time? What's the smallest the angle can be? Well, the angle could be 0, so you got to try that. Okay, it might be the fastest way just to paddle through the entire lake and take the shortest distance. That might also be the shortest time. And what's the biggest angle you can take there? Well, you could do none of the river or the lake and just go straight up and bike along the whole edge. I think in this question it's biking. It could be biking or walking. So you have to try theta is equal to 90, and you have to try theta is equal to 0 also. So 0 or pi over 2. Okay, so try those ones also. That's where they're tricking you in this question. It's not really tricking. It's legitimately a good question. I didn't get this for a long time. I had to toy this for a really long time, and look up solutions. Okay, so I looked up what to do. I spent maybe like a few hours staring at it and trying to figure it out, and I didn't get it, so I just looked it up. All right. So yeah, that's that. So as always, if you want me to personally help you pass your course, I would love to. I'd love to help. I love doing that. It's what I do. Go into the description and click sign up for the newsletter, or send me an email at tallguytutoring@gmail.com. I will get back to you very shortly. We're ramping up for exams now. It's going to be awesome. I'm meeting with the class every day for like 3 or 4 hours, especially when classes end, which is, I think, this week. We'll be meeting for about 4 hours a day until your exam. So yeah, if you want in on that, let me know. I'd love to help. Anyway, hopefully this helps, and we will talk to you guys tomorrow. Have a good day.